Yeah, it's recording. Yeah. All right. So this week I wanted to talk just to go back to kind of more biostats stuff. So we're working more on my original plan had been to cover uh, survival analysis, multi-level models, and estimating equations. And after I got through multi-level models, I looked at the week 8 file and thought, wow, that's a lot of stuff. So I just stopped there. Um, I might do generalized estimating equations next week. We'll see. I might also do XML and JSON processing next week. I think that's. But I'll do just generalized estimating equations if there's an interest. But I want to talk about these and also within this in the multi-level models one in particular. I have a section wrong there. I want to go through kind of an analysis and we can practice with our tidyverse stuff as well. But just a refresher on survival analysis, we're working on survival analysis is time to event data. So we tend to need either 2 or 3 data points. So we tend to need a start time, a stop time, and then an indicator whether the event occurred. So the often the start time is 0. So we think of it epidemiologically as a 3 variable outcome, like start, stop, event. But in reality, it's often it's often just time and event, because some people will often like reset everyone's start time to 0, so you don't have to pass it if it's 0 for everybody. So we often, and I think in most of the examples I have today, rather than being start, stop, event, it's just time and event. So the idea here is we're looking at things like time to infection after surgery, time to death after breast cancer diagnosis, time to relapse after entry into addiction treatment, or time to relapse after discharge from addiction treatment, depending on how you want to measure your start time. And all of these are survival analysis is important because why it's complex is because of this censoring, is that not everybody's going to experience the event. So we have a time we follow people, but you might follow someone for breast cancer, and after 5 years you decide I'm going to stop following them, or after 2 years they die of an unrelated issue. Those are both examples where they survived for a certain amount of time, but they left the study without experiencing the event. And it's this idea of censoring that not everyone is going to experience the event, but just because they didn't experience the event, we want to use the time that they did experience the event in the analysis. I won't go into the methods too much. I can share the material I teach in my biostats course. I don't think any of my students, Samantha's seen that before, but I don't think anyone else has. But yeah, so we are going to fit it largely with the same kind of, so the 2 functions we're going to look at is serve_fit is the function for fitting Kaplan-Meier curves, and Cox-PH is the function for fitting proportional hazards regression models. And they still follow that same general structure of y tilde x or y tilde x1 plus x2. Like it's still that same equation modeling. The only difference now is that our left side of the equation, rather than being just a y, is a more complex object, because we need a way to specify that we have a time and a censoring variable. And we do that with this serve object. So we can see serve_fit is, in this case, I'm doing, when you do tilde1, 1 means in essence just fit it on nothing. So just build an intercept model. Like if you wanted to build a regression model with no predictor for one reason or another, you would do y tilde 1. So that's how you build a regression model with no predictors. So in this case, I'm building serve_fit as a Cox proportional, a Kaplan-Meier curve. And my left side, rather than being y, is this serve object. And if we look at the help file for serve, we can see that it takes a time, sometimes a second time, and an event. So it has a 1,0 variable that describes whether you experienced the event or not. So 1 means you experienced the event, 0 means you didn't. And then it takes either one time variable that is the time to the event, or you can pass it a start and a stop if you have 2 time points. I almost always do it as a 2 variable situation. So I almost always do it like this with serve and the time of follow-up and the status. Now, the I think SAS might do it the opposite way, but it's you always the biggest concern I always have is making sure that my status variable is coded 10 the right way. So in R, your censoring variable is a 10 variable where 1 means you experience the event. So you want 1 to be death or 1 to be infection. If your indicator is a dropout variable where 1 indicates dropout, you would want to switch it. You'd want to go 1 minus that variable to be your event indicator. You want to make sure that that's coded the right way. So once you've got that correct, you get an output object, and then this works similarly to what our regression model objects were. So we can call it, and it will just give us a brief summary of the Kaplan-Meier curve. So number of subjects, number of events, and median survival time. And I think these are the confidence intervals on the median survival time. This summary table is really useful mostly for this events number, because that lets you check to make sure you've coded your censoring variable, your status variable correctly. So you should know before you start how many events you have. So I had 165 events out of 228 subjects. I want to make sure that that's actually what I expected. And if it's not, then I must have coded my status variable wrong. If you do a summary on the object, and this is actually not that useful, this gives you the full life table. So this is that this gives you at each time point where something happens, the number of people in the study, the number that experienced the event, the survival curve. This table is useful when I'm teaching. I never use it practically. But if you need the actual survival table, you could use this. If your data is more interval measured, like rather than individual time points, you only have like 4 weeks, 8 weeks, 12 weeks, 16 weeks, 20 weeks. Like if it's just monthly, then this table could actually be kind of interesting because it does. I mean, this one isn't interesting because it has so many rows. But if your data is made up of few individual time points, then then this table can be useful. But in general, I don't find I use it that often. So a more interesting Kaplan-Meier curve is actually stratifying by something. So I'll plot both of them later. So if we do a tilde on the sex variable, and I think at the top, yeah, so I guess I should talk about this a little bit. So there's a built-in data set called lung. If you just type the word lung, you'll get a data set. And if you do look at the help file for lung, it describes exactly what it is. I just did a little bit of adjusting. So I turned sex into a real sex variable with a factor variable with the correct labels. I created an age group variable rather than an age variable. That was just because I wanted another multi-level variable for my regression. And ECOG score is coded as 0, 1, 2, 3, but after discussion with an oncologist several years ago in my stats class, it makes more sense as a factor variable. It's more ordinal than it is categorical. It's more ordinal than it is continuous, where like the jump from 0 to 1 is more serious than 1 to 2, and nobody gets a 3. So it made more sense as a factor variable. So this is just a little bit of data pre-processing. You can see I do a similar thing here with our multi-level data. But if we scroll down, so I fit a regression model on sex, and we can see the summary table now gives me, I have 138 males of whom 112 experienced the event, 270 week median survival for males, 420 week median survival for females. And again, the summary table is now stratified. So this is the summary table for men, and down here we have the summary table for women. Again, the summary tables for most of your survival analyses aren't that useful. And as you can see, they actually print out a ton of stuff. So I would caution you against doing them most of the time. But if your data is very interval measured, if you have few individual time points, the life table can be pretty useful. But Kaplan-Meier curves are for plotting. That's why they're called Kaplan-Meier curves and not Kaplan-Meier analysis. This survival curve is what we use most of the time when it comes to Kaplan-Meier curves. So if you just plot a Kaplan-Meier object, a surf-fit object, you get a Kaplan-Meier curve with confidence intervals. And you can see this is the second one. So I have a separate curve for males and females, and I cleaned up the axes. I added a days label here, better main label, that kind of stuff. It's a nice quick way to do this, and I would suggest doing it fairly often, because it's, even if you're doing a Cox proportional hazards regression, you often want to start with a bunch of Kaplan-Meier curves, because they're a quick way to know what you're looking for, because Cox proportional hazards regression doesn't have a good visualization tool in itself, right? It's similar how you do scatter plots before you do a multiple regression. That being said, these plots are a little bit ugly, so I like the ggserv plot from the, what's it called, ServMiner? Yeah, so there's a library called ServMiner with a function called ggservplot, which does Kaplan-Meier curves within the ggplot framework. So you can see that if I do ggservplot on the same object, it just gives a little bit of a prettier plot. And the other nice thing is that because it's so I changed some things. I added the p-value. So this is from a test of some sort. Does anyone remember what's the test on the Kaplan-Meier? It must be a chi-square test. I don't know. It'll come to me. It's a p-value that tells you if the curves are different, and I can look up in my teaching notes what exactly the test is. I don't tend to use Kaplan-Meier curves for testing all that often. If I want to test a survival curve, I'm going to do similar to, I don't do t-tests that often. If I'm going to be testing something, it's usually a linear regression. But you can add the p-value to the plot. What I like, in that it's this number at risk table that really makes it useful. People like this a lot to understand at each time point how many people are left. You can infer that from the sizes of the steps down and the width of the confidence interval, but this is a nice addition to the figure. And the nice thing is that because this is a ggplot object, I can use the plus function to add things to it. So I can, at the end of the function, if I do a plus, I can start adding other ggplot arguments. So I can change the labels. I don't know what would happen. I could add, if I added geom.point, it would probably go all wonky, but I could do other things to make it a little easier. I can't figure out how to get rid of the word strata, and it's a tiny bit annoying, because you should be able to, and I just can't figure out how they passed it. So that's the basics of Kaplan-Meier curves. If you look at the help file, and there's some good vignettes online for ggservplot to see how it works a little more. But Kaplan-Meier curves are largely an exploratory method, right? It's what you do before you get into the modeling, which I'm going to do with Cox proportional hazards regression. It tends to be how I like to do all my survival analysis. And it looks much the same as Kaplan-Meier curves. It still has a survival object on the left side, and then the right side is going to be the variables that you're stratifying by, or that you're predicting by. So if I just run CoxPH on sex, this is the same as the Kaplan-Meier curve, only I'm fitting it as a regression model. One of the nice things about proportional hazards regression in R that Stata doesn't have, SAS probably, I can't remember, SAS must. I can do an ANOVA test on a proportional hazards model to evaluate the variable. So this is the equivalent of, actually, I'll talk about this more in the multiple model. It doesn't make any sense in the individual model. But when I do a summary on the model, I get the coefficient, and then I get the exponentiated coefficient, which is the relative risk, a p-value, and then it gives me, this is something that it gives, CoxPH gives you that LM and GLM don't, is it reports the confidence intervals in the default output. You have to use the confident function to get the confidence intervals from the other one. But this is useful, so we can see that the effect of sex is significant. The relative risk is about 0.6 with a confidence interval of 0.4 to 0.8. Now for a multiple model, and this is where the ANOVA command becomes useful. So now I'm predicting survival as a function of sex, age group, and ECOG score. So age group and ECOG score are both 4-level factor variables. If I look at those, ECOG has it. I say it's a 4-level variable. It's really a 3-level variable. One person had that higher ECOG value. And if I look at the age groups, I think they're a little more balanced, mostly above 50. But other than that, they're pretty well balanced. But both 4-level variables. And we can see that what each of these does is they fit the model with that variable included and then that variable dropped, and measure the change in the log likelihood. -2 times the change in the log likelihood is a chi-squared variable, so that makes it a chi-squared test. So it's a likelihood ratio test the same way that uh, logistic regression we do likelihood ratio tests. The nice thing is that this single ANOVA command will run a likelihood ratio test on each of my 3 variables, where in Stata there isn't a single command to do that. You have to do it manually. And then the other nice thing is that if you have missing data here, the models don't get mismatched. I'm sure you've all experienced the challenge of trying to run a likelihood ratio test, and the program warns you that it can't do it because one of your models had 7 more subjects than the other because you didn't manage your missing values. Now, we should all manage our missing values better, but who wants to do that when the functions can do it for us? So I like the ANOVA command for that purpose. And then the model is the same. So we have the coefficient for, here's the relative risk for females. The age group effect isn't significant, which is confirmed up here. And then the ECOG scores do look significant. And there is one of the nice things about ECOG score here is that there's this nice increasing relative risk pattern, which is kind of demonstrating that ordinal effect that we were hoping for. I would take this one with a grain of salt because there was only one person with an ECOG score of 3. And that's good, but the nice thing about ours, I don't have to deal with this output. I can produce the tables automatically with some of our tidyverse stuff. So if we run through these commands in sequence, so if I run this command, we see coef gives me sorry, I'll make this a little, gives me the coefficients. It just pulls that coefficient table out. Morning, Dan. One of the commands you'll see I use a lot here is row names to column. So when you pull out, if we look at just this, like if we just pull out the coefficients from the summary of itself, it's a 1, 2, 3, 4. It's a 5 by, or I guess 1, 2, 3, 4. It's a 7 by 5 matrix, but it has row names for the variables. And as the tidyverse people point out, they don't like using row names. Row names are essentially the same as a variable, but they follow different rules. So if you want to access the row names when working with the tidyverse, so the first thing I do here is I converted it to a data frame, and nothing much is going to change here. It looks essentially the same. And then the next thing I did was this row names to column command. And all that does is it takes this data frame, it takes the row names, makes them a variable called row name, and then changes the row names to just 1 to 7. The reason I need to do that is when I pull out my confidence intervals, I want the same thing because I want to combine this matrix and this matrix. I want to combine the coef and the confidence interval matrices, or I guess they're data frames now. And I want to match them on row names. And these functions we've learned, this left join and right join function, only work on variables. They don't work on row names. So you'll find yourself, if you're working with the tidyverse and you need to access the row names, you're going to use this row names to column function a lot. And it's something that's useful because row names get chopped off by some of the tidyverse functions. So then when I join the two, if I do this command, we can see that this it just combines this data set and this data set and joins them on probably row name and excoef. Like it just joins the two so they match up correctly. And then because this one now has way too many variables, I just use the select command to pull out the exact variables I want. So I want the row name, I want the exponentiated coefficient, I want the lower confidence limit, the upper confidence limit, and the p-value. And then I just rename 2 of my variables. So I don't want this called excoef. I just want it called relative risk. And I'm just going to change row name to variable because that's a little more intuitive. So if we look at out 01, this now gives us the relative risk and the confidence interval and p-value for a single, for all the coefficients in our Cox proportional hazard regression. And then I just run it through cable. And the only thing I've done here is pass it through cable, set the digits. So I obviously there are no digits for the character column, and then I've got 3 digits for the relative risks, 2 digits for each of the confidence intervals, and 4 for the p-value. And then cable styling is the thing that just makes it print to the output area. Now, if you're a lunatic like I was the first time I tried this, you can do this all in a single command, so you don't need to create coef and ci and outa1. You can do it all as a single set of pipes. One problem with this is I think I said when we first learned pipes that you shouldn't do more than 10, and I do have 12 in this command. So I have broken my own rule, and also when you look at it, it's a mess. It's got pipes within pipes. It's not a good way to do it, but I did want to show that you can do it as a single command. What I actually might do, what I would probably suggest is this step here is the useful one. So if we look at this, this takes a model, a Cox proportional hazards model, and gives you this table. What I might do is take that command and wrap it in a function and save it. So I was actually thinking last night I should do it, but I had other stuff to do. I want to save that so that the next time I'm working with Cox proportional hazards models, I can run a single command and get this output, which is a combination of the output from the other tables. The rest of this is just this last command I would save, and the packing the rows is that you don't need to do that. That's just making it slightly prettier. But the row names are so ugly that you can only do so much. So that's about it for survival analysis. I guess I didn't mention it. If you plot the Cox proportional hazards model, I believe plot 1.102. Oh, serve plot? What's it called? I can't remember what the command is. I'll have to dig it up. Or no, you can only do it with, is it? Plot. No. I have to go back and look. You should check the assumption of proportionality that is important for survival analysis, and there is a plotting function to do that within R. I just can't remember what it is, but assumption checking. I trust that you'll all do it correctly. I'm not that worried about it because we all definitely do it every time, right? So moving on to multi-level models. So I want to talk about multi-level models, and we'll also talk a little bit about the exploration that gets us to multi-level models. So there are several ways to fit multi-level models in R. This is a sentence that this sentence, there are several ways to fit multi-level models in R, but the most common are LMER and GLMER functions from the LME4 library. Every tutorial on multi-level models online says that. I don't think there are multiple ways anymore. I think it's just this one. I think the other ones have gone away because every tutorial starts this way, so every way that wasn't the LME4 library disappeared. I'm sure there are other ways, but the LME4 library, which I think is written by Doug Bates, and I'm sure a ton of other people, is the way to do it. So I'm going to focus on using multi-level models for random intercepts or random slopes. You can use mixed effects models for longitudinal modeling as well. When I'm doing longitudinal modeling, I prefer GEEs, which, as I said, I had hoped to fit in here, but I ran out of space, so I'll do it at a later time. You can do longitudinal modeling with mixed effects, but I think estimating equations are more flexible for longitudinal data. Also, I'm following this UCLA stats page tutorial here, which is good, but is 10 years old, and it suffers for that just from display and communication perspectives. So the way we specify the models, because that's really the complex part, is I'm going to make this big enough that we can see. So the traditional like for a linear regression, we would do like y tilde x or y tilde x1 plus, like if it's a multiple model, we would have multiple x's, right? With multi-level modeling, we want to be able to add random slopes and or random intercepts. I say and or. When I was preparing this, it got me thinking, is there ever a situation when you do a random slope without a random intercept? And in my searching for advice, I found far more people saying don't do that than telling me how to do that. You can do it, but I'm not going to tell you how because apparently you shouldn't. Like, it's a weird situation where you want random slopes, but you want to force every intercept through the 0, 0 point. In general, like, I've only done fixed intercept modeling a couple times in my life where we knew that beta naught needed to equal 0, like when x equals 0, y has to equal 0. That happens so rarely that, but if you encounter it, let me know, and I've seen people do it. It's just you probably shouldn't. So the way we specify the random component in LME4 is we within brackets. This, you can think of, it's the way it works is the thing on the left side of the vertical line is our random intercept equation, and then the thing on the right is what we are grouping by. So in this case, what this is saying is we're only going to have random intercepts. And this goes back to what I was saying before, where if you do y tilde 1, it fits a regression model with just an intercept. When I do one group by group, one vertical line group, it says I want to get this model randomly for each level of group. But this model is only going to be an intercept. In contrast, if I fit this says predict y with x1, x2, and x3 as fixed effects. And then in my random component, I want a random slope on x2 for each level of group. And it's inferred that if you have a random slope, you have a random intercept. So yeah, so that it's just about learning how to do this. And if you have multiple random components, let's say you're looking at, I saw a data set online last night that I didn't bring in because it was too big, but it was looking at student ratings of instructors. So that's an example where you might have two random intercepts, because what you want to study is like the effect of grade on rating. So you have their grade in the course, and you have the rating they provide the instructor, and you want a random intercept for each rater, which would be each student, and each professor, which would be each slope, because those are the components that would be compromising the independence of the data. And in that case, the variables are so big and the groups are so small, you might just ignore it and do a linear regression, but you probably shouldn't. So this is the example from the UCLA Stats website. And one of the big problems I had is they use this data set called IMM10, and I cannot find the documentation for it. The reason it's called IMM10 is it's the 10th data set from the Introduction to Multi-Level Modeling online course that UCLA offers. It's not a bad course. I numbering your data sets 1 to 10 in your textbook is just a recipe for disaster. So I'm going to make up what a lot of these variables mean. We can kind of infer. We're talking about 260 subjects from 10 different schools. So we're going to focus on their math scores as a function of their dedication to homework. So we have a math score variable. Here we can see that I took the data set's called dat.imm. And if you go up to the top, IMM's read from this UCLA Stats website, and the only thing I changed was I created a factor version of that homework variable. And you'll see later that's just to make the colors a little nicer in one of my plots. So I passed that to ggplot. I want to put math on the x-axis, and I just want to do a histogram. So this is just a brief introduction on what the math scores are. So we can see the math scores range between 30 and 70, so not the easiest math exam. Probably a fair. I know that when Nova Scotia used to have a standardized test in math, the average was in the 50s, so that's probably not inaccurate, but that is a low number. And we can see, looking like there's no real noticeable pattern there. For this one, I actually want to take you through the process I went through to build this plot, because it's a little more interesting than just the plot itself. So we're on this one. So what I did was, I knew I wanted to do a scatter plot of math versus homework, because that is ultimately what we're interested in. So I did dat.imm ggplot AES x equals homework, y equals math plus geom point. So I started with this plot, and this is the relationship between homework and now this was the first place where I actually decided to switch to jitter. Jitter isn't a function you might know about, but basically when I look, I'm getting banding here. So homework, again, I'm going to assume is the number of days you say you do homework. So a bunch of honest high school students who say 0, a couple dishonest students who say they do 6 and 7, the rest are somewhere in the middle. So if we look at geom jitter, the same thing. What jitter does is it adds a random component to the X and the Y axis. Now, we need to control this a bit. I don't want things to jitter into the next column. So I'm going to reduce the width to 0.2 just to make it clear that like these are all the zeros, these are all the ones. I don't want to confuse that, to make it look like we have fractions here. And I don't want any jitter on the y-axis, so I'll set the height to 0. So that's the same plot, it's just a little easier to read. And then if we do geom smooth, we get the line on it. So that's not a bad place to stop. But I wanted to see, I had actually done the violin plot before I had done the, oops, oh, that's a line too high. There. So that was, I wanted to do a violin plot for each one. That didn't work very well. So then the rest of what we're doing is just working on the coloring and formatting. So I need a group variable. So I'm going to group by homework. Oops. Okay. Bracket. And that gives me a violin plot for each one. And then I had tried color equals homework. And this works, but I didn't like the gradient. So this is why I created that factor variable at the top. So when you pass color as a continuous number, when you pass color a continuous number, it gives it a gradient. If you pass it a factor, it uses the palette. And I wanted I use the rainbow plots whenever I can. I just think they're pretty. And then the last thing I did is, because the violin plots are colored, I decided I wanted these to be colored as well. Comma there. Take out a comma there. That's how I ended up with a pretty plot like that. So you can see how it's built in parts, right? And in reality, this, depending on, I guess this is where you would stop from a data exploration perspective. Like, I don't know that the violin plot and the colors added a ton. I think it made it nicer. And it might, like the shape of the violin plots might give you a little bit more information of the distribution at each level than just the dots, but the dots were probably fine the way they were. So the next thing I wanted to do is I wanted to see how these two plots differentiated by school, because we do have that school grouping variable. So if I use the facet wrap command, so I took, this is exactly what I had for my first one, right? It's the same histogram, but I just added a facet wrap by school ID. So now it gives me a different histogram for each school. Now the histograms are kind of bad because it uses a unified y-axis, and obviously most of them don't get a ton of value, but you can still see here variability by school, right? There's 6281 looks like a big school that did a lot better than the other schools. The other schools seem like they're more in the lower range, but even then, even amongst, if we ignore this one, the other schools, we have some low values here. This one's more distributed. This one's more distributed. This one's clunked at the bottom. This one's more in the middle. Like there is certainly variability by school. And we can see that even more. I took the dot plot command. I pulled out the violin for the facet wrap because the violin plots just get really useless in small sample sizes. But I took the same line plot and I did facet wrap by school ID. And this gives me the relationship between homework and math score for each school. And what we see there is that there's a different pattern, right? The relationship between homework, number of days doing homework, and success on the math exam wasn't consistent. Some schools were significantly positive, moderately positive, significantly negative, though this might be outlier driven by these couple significantly positive, negative, negative, positive. Like it's there's a lot of variability in these curves. Now these are low S curves, right? These are just the curves are just done by smoothed averages. They're not. I could have added linear regression lines, but I didn't want to. So I just wanted to see. This is good evidence that we need a random effective school, at least a random intercept, and probably like so. This is good evidence we need a random intercept, right? Because the math scores seem different between school. This is good evidence that we need a random slope because it's not just that the math scores are different between school, which is what we see in a lot of Nova Scotia data. I know that a number of students have worked with Sarah Kirk's data set on success in school. What's it called? Blue Nose, something like that. It's an excellent data set. I should know the name of it. Because my sister-in-law did her thesis on it. But it's a good data set and it has a lot of this stuff. They almost always fit those with at least random intercepts because the success per school is so different. But that data set has not found as many random slopes because after factoring out the baseline differences in school, the way that, in her case, nutrition affected success in school was the same across schools. In this case, it's not just that math scores are different, but the way homework is influencing math scores seems different in every school. So we should investigate random slopes. So this is an interesting command. So rather than before I fit my random model, I fit a bunch of linear regressions. So I just fit a simple linear regression predicting math with homework for each of the individual schools. So what the by function does, it takes 3 arguments. The first is a data set. The second is a variable that is going to split that data set. And then the third is a function to apply to each split data set. So in this case, I took dat.im and split it by school ID. That will then give me 10 individual data sets. Then on each data set, I did a simple linear regression predicting math score with how much homework they did. And if you look at that individual object, this one, lin.mods, it's a weird kind of object. It's separate. If you look at the class of it, it seems like it should be a list, but it's actually a special kind of list called I think it's called a by. So it's like a list, but it has 10 elements. So we can see this is the linear regression for school 72292. And what I did was I ran sapply, something you'll find a lot. So sapply takes an object and applies a function to each object. So this takes linmods, which is a set of linear regression, and applies the coef function to give me the coefficients for it. I just want the intercept and the slope for each linear regression. One of the I find surprisingly frustrating things with sapply is that it almost always returns my data in the opposite format that I want. Right? I want the rows to be schools and then one column to be intercepts and one column. And it almost universally applies them the wrong way. So it's a good opportunity for you to learn the transpose function. So transpose just flips things. It's a matrix function, right? To turn the rows into columns and columns into rows. So the point I'm trying to get at here is that both the intercepts and the slopes are wildly different between the schools, right? We have intercepts as high as 50, so kids that did no homework averaged a score of 50, 59 here. And the slopes are different from a gain of 8 points per homework to a loss of 4. So this is all good justification for random intercept and random slope model. So the way we've built it is like this, that we want to predict math with homework and we want a random effect of homework per school. Now this is one of those common places where we want both a fixed and a random effect because we want to know the overall effect of homework while factoring out the school specific effect of homework. So when we print this model, we can get our fixed effects. So this is after accounting for a random effect for each one. We have an intercept and a slope. If we run ANOVA on this does the same kind of chi-square testing we did before. It's obviously not that interesting because we only have one predictor. But if we do the summary of the model, you can see we have the fixed effects here and then some summaries of the random effects here. I'm not going to get into what to do with the random effects because what you do with your random effects varies wildly based on the purposes of your modeling. And you can see that there's a variable that indicates whether they're public or private schools. And we can add that to the model as well. And this just shows that homework is still not significant. And that's interesting, right? So one of the things we find in this data set is that this looks significant, right? The initial study looks significant, if maybe a little bit weird the way it bows down. But it really does seem to be school driven. And when you factor out the individual effect of homework in each school, then what's left is a fairly, where'd it go? A fairly weak homework effect, right? So once you factor out the school specific effect of homework, there really isn't a universal effect of homework. Some were very positive, some were very negative. And you can do summaries and things like that. And then we can build the interaction effect to see if there was an interaction effect between public and homework, and I don't think there was. So there wasn't, so we would just drop the interaction term and keep going. So that's it. So for the breakout activity, and there are only 7 of us here, so 6 and me. I think I'll just leave you in a single room rather than split you into 2 rooms of 3. I'll take my headphones off for 5 minutes. You can talk without the teacher listening, and then I'll come back. I want you to work with 2 data sets. They're both built in. So there's a library within survival. The survival data set has a ton of interesting The survival library has a ton of interesting data sets. We're going to use one called Veteran, which is comparing 2 treatment regimens for people with lung cancer. So I want you to take that data set and show the Kaplan-Meier curve for survival based on the 2 treatments, along with the Cox proportional hazards model for treatment, cancer type, and age. And then there's a library called MLM Rev. I don't know what that library does, but I do know it has a data set called Exam, which is the exam scores of about 4,000 students across 65 schools. So I want you to build a multi-level model on that data set. Both of these are built in. So if you want to, because you're going to need to know what the variables are, if you do veteran, you get the help file on that data set, and this will show you what the variables are and what they mean. And likewise, if I get the help file on exam, we can see a definition of what all the exam variables are. So my timing's getting better at this. I actually left us time to do it. So we've got about half an hour, 15 minutes per breakout activity. And I'll leave you guys a couple minutes. I've got some emails to answer, and then I'll come back and give you some help.
Nice.
So I guess this is the breakout room.
Yeah.
But he's recording it, so nobody say anything bad.
Good call, Dan.
Just a point of order here. It seems every time I try and run R to participate in these things, a million things need updating. Did you guys get a lot of like update warnings when you're trying to install this stuff? No? Worked fine? Whatever Boomer is, I can't even find it.
Oh yeah, Boomer is a package he uses to like check to see where things break. So I don't think you need it.
Yeah, my code is always perfect.
Yeah, that's what I was thinking.
Okay, so are we all forced to look at his screen here? Can we close this?
I don't know if we can. Can we change? Can we even share a screen?
You'll control the content the presenter is sharing. Daniel Dutton is requesting control.
I don't know.
Yukiko has sent a message. She'll be back. Okay. Well, I am installing literally everything, so I can't really lead the activity here. And I was late.
Oh yeah. Where was? Second. 137 observations. Yeah, it's weird we can't share a screen.
So have you got it? You got it going already? It's just application of the commands we've already learned here.
I think so. I think because we just need to do yeah, the graphs he was doing at the start.
Maybe I can ask a more general question. So there's lots of jargon. When Sam was talking about random effects here, I think it's my understanding of like what people mean with random effects. I do not think that means a dummy variable for each school.
No, I think that's when he was talking about fixed effects, because he also had fixed effects talking about.
Right.
Yeah, random effect is that then there's the, it's, yeah, exactly that. It's
Okay.
not the, yeah.
Yeah, I don't know. I think I don't really know very much about random effects.
You've probably seen it before. It has to do with giving part of the error that you would normally attribute to each observation to be sort of shared amongst groups. And so here the groups are the schools, but with people over time it would be the person.
Oh
So
yeah.
it's the correlated observation. So here it's if the observation is repeated within the individual, those observations you would expect is much similar than some other person. Or if you are in the same school, you probably share certain characteristics. So it's not the independently distributed within that cluster. So whatever way you identify cluster, you want to account for those unequal variance.
Okay, that sounds quite similar to fixed effects.
Yeah, but in a fixed effect, and you just fix it. Lack of better word.
So some
There's
language I've seen to describe what you're calling a fixed effect, Kent, is
Yeah.
a within model. Some people call them within models, if that
Yeah,
language
yeah.
helps you.
Yeah.
Meaning it's the within observation variance in whatever it is you're talking about. And generally this operationalizes as time demeaning, taking the average of something and subtracting that average from each observation. This is the fixed effects error treatment in econ. But unfortunately, some people call the fixed effect the actual variable you put in the regression. They say this is the fixed effect for being a man or the fixed effect for a school,
Oh
which
yeah.
leads to massive confusion.
Like
If
the
you just say
dummy.
fixed effect, random effect.
Yeah.
But it is an interesting question. It's like, okay, so Sam threw it up there. He's like, these schools are different. So naturally, the first place we're going to is a random intercept for each school. But some people would say, I want to put in a dummy variable for each school.
Yeah.
So I see. So I actually, if I keep updating R, it'll keep downloading stuff. So maybe I'm just like completely out of date over here. Maybe that's the problem.
Yeah, I
Maybe.
wish you could share your screen. And then, is it like you don't have the packages or the?
If I go to Tools at the top of RStudio and I click Check for Package Updates, it keeps telling me there are updates, and it's always a bit different. And so I'll install them. Let me see where I'm at now. It keeps having to shut down after it updates these things.
Yeah.
But I'm getting there. There's only 4 left.
But do you try to update everything? Okay, that's why. Okay. I never checked that. So maybe yours is set up as that, and every time you open, you check update or something.
Well, you know what was doing it was I would try and install one of Sam's packages, and it would say
Yeah.
like all of the other packages this is supposed to call is out of date, and so that's where I started updating everything.
Okay. Yeah. Yeah. I think I just don't have that many things. I need to get these things first.
It's kind of it's a massive distraction because I'll show up to the R session without having prepared anything, and as he's talking, I'm trying to quickly update all the packages.
Right.
Sam, you shared your screen and we can't. Oh, he's got it. Hey Sam, because you didn't put us in a breakout room, all this was recorded, so you can watch our discussion. But also, we weren't able to share the screens.
Oh, really? Sorry.
Yeah.
If I stop sharing, can you share now?
Somebody competent should give it a try. I'm installing packages.
Oh yeah, I think we can.
I think you just couldn't. Maybe you couldn't steal it from me. There we go.
I can stop sharing if someone else wants to.
No, this is good. You take it away, Kent.
I'm trying to just download the package.
What are the new packages this time? There's the MLM Rev. Oh, LME4, Haven, maybe. I guess there are a bunch, aren't there?
I couldn't find Boomer.
Oh, really?
It's in it already. Isn't it introduced weeks before?
I think I showed it to you last week.
Whoa. Mine already has it. You don't have it then?
Last week I was indisposed, so I couldn't come.
Oh, yeah. Right. You're not here last week.
Is it not on CRAN?
I suspect this has to do with my chronic update problem here, which I've been working through.
Okay, so it should be
I feel GitHub rolled out a dark theme halfway through my work on this last night. It was really confusing. I like that GitHub has a dark website.
Oh.
But it was so. Unless some people, because I feel like earlier in the day I went to GitHub and pages were regular, and then later in the night I was on GitHub for on someone else's GitHub page looking for some code, and it was dark, and I couldn't figure out oh, this is so cool. They found a way to make their GitHub dark, and then I went to my page and oh, they found a way to make my GitHub page dark. How'd that happen? But it's apparently the default setting now. I like it. I like a dark theme.
Yeah.
Saves my eyes.
Yeah, I switched it over. Yeah, because you could switch it over a little while ago. I was playing around.
Oh, could you?
Yeah. So I guess I just switched it to default.
So I just posted a link in the chat to the this Boomer library on GitHub. But you might need to install it directly from GitHub. It might not be in the CRAN. But it's really useful for seeing expanding what's happening in a bunch of pipes.
It's telling me that Boomer is not available for my version of R.
What?
I got the same message too this morning, and but I just had to use the install the packages or something. Yeah, I had to do that this morning.
Anyway, I mean, we don't use it today. It's not the most important. It's a useful debugging tool, really.
Guys, my son needs glasses.
Oh no.
Oh, no.
How old is he?
It's like 5.
I mean, look,
Oh.
it's great you're able to diagnose it so early.
You believe it?
He's lucky that glasses are cool now. You're still gonna have to spend so much money on glasses over the next 15 years.
Glasses, teeth.
I can't imagine how often a 5-year-old's going to break his glasses.
Oh no, they have these ones that you can just twist like they're a
Oh,
sponge.
great.
Yeah,
Okay.
yeah.
And
Yeah.
the lenses are essentially plastic.
Yeah.
Like they're a glass that works like plastic. That would be my worry. A friend of
Well, I
mine,
think-
she's a teacher, and she found out her kid needed glasses when he was 8, I think. They were commenting on road signs, and he talked about how blurry they were, and it turned out he just hadn't been able to see in school all that well for his first 3 years.
Oh my.
Yeah.
Is it something you grow up? Some kids' eyes, once it's bad forever.
I think so, without intervention. I don't know if vision problems are things that get better in kids. I can't think of any. I have some friends that, like my friend
Yeah,
Josh,
some
growing
kids.
up, like when he was a kid, he was like his glasses need to be everywhere or else he can't manage. And as an adult,
Yeah.
I now think of him as like wearing glasses for work, but not wearing glasses all the time. So yeah, maybe. I mean, I don't think he just started wearing contacts anymore.
I think some people do like a corrective glasses when
Yeah.
they're kids. Is it different thing?
I don't know a lot about that. That could be it, though.
I think the problem here is that they were talking to Pat about Pat's my wife, and if you tell her that he has a healthcare need, she springs into action. If you tell me he has a healthcare need, I say, hey, fine, glasses, come on, what's he? He's not reading anything that important, so.
Just tell him to lean in, squint, or lean back and stop squinting. One of those two.
He's been reading books this whole time. What's he been doing? Faking it?
That's pretty good. He's 5?
Yeah.
Wow.
Okay, is there a way to update R, like core R from the R Studio that I'm missing here? Because it seems like it's warning me that all my packages are newer than my R.
So the warning about packages being newer than R isn't a huge problem. I'm starting to get that now too. I noticed when I installed MLM Rev or Haven, one of the ones I installed last night, or two of the ones I installed last night that I hadn't had before, gave me that error. But I'm on. Just the word version, it'll tell you what version you're on. I'm on 403, and I think the most recent release is 405. I'm not going to go out of my way to, because the thing is that when you update your R, you need to update your libraries as well. There's a library called Update R, update with a capital R at the end, that'll help make this easier, but it doesn't change the fact you need to download a whole bunch of stuff. So I only tend to, like, I probably won't update my R until it's 4.1 point something. Unless I'm really bored or a library starts giving me a hard time.
Okay, acknowledged. It's just I get all these warning messages, freaks me out, but I guess
Yeah,
it's
it's one thing I wish our studio, I wish they would color warnings differently than errors, because they don't differentiate them, and warnings can vary from this didn't work to just a heads up. And I wish that, like, I wish in the output, yeah, like errors were red and warnings were yellow or something.
Kent, you're doing fine work over there.
Thanks. I don't know. I think I'm going a little slow here with.
Well, I am updating packages, so you are much faster than me.
Okay, I have a really silly question. How do you like veteran data? How do you get it? I mean, it's a built-in, but in a
So it's what once you've loaded the survival library, It's just there. If you type the
it's
word
in it.
veteran, the data will work.
Okay. Okay, got it. So I should be able to go right away.
So yeah, you can see in Kent's example, he assigned veteran to an object called dfvet,
Yeah,
and then he uses dfvet for all his. That's not a bad thing to do because like I did a similar thing at the top of my file, and part of the reason I
Yeah.
did that, like you can see the first thing I'd done, I had dat.long equals long, and it's because when I wanted to make change to the data set, I didn't want to change the core one, because then if I made a mistake, I wasn't sure how I was supposed to reload it. I might have to like restart R or something. So when you're working with these built-in data sets, it's probably a good idea to assign them to your own custom variable and then work with that
Yeah.
custom variable, just so you can make changes without worrying about breaking the source one.
So this, sorry, I think you said this, but it's the def vet after this this sign, the smaller than, greater than, minus. Isn't this another way to write it too?
Oh, the arrow.
Yeah.
Yeah,
Arrow.
so that's the same as equals.
Okay. When I write equal, it doesn't work. So I'm wondering. Let me try. No, it doesn't work, so something is wrong. I'll figure it out. No, I do have some problem. What's wrong?
This serve plot also has a big pet peeve of mine when people write ggplot friendly functions but change the baseline plotting theme.
Oh yeah.
See, it
Like the
changes to
colors?
Yeah, just like the default is called classic, which in their defense does seem like it would be the actual default, but the default is called theme gray. And I really like the background grid on ggplot function. I don't need the gray, but I like the white lines for the grid, and you can't see them in the default value they have set up.
I have seen people suggest that de-bizifying a graph by removing the grid makes it sort of easier to look at.
Oh, interesting.
Yeah, I don't know where I stand on that, like minimalist graphing. Because like, if you just want to see a line that goes down, I can draw that on a whiteboard.
Yeah, I think it's
I kind of like black.
it's very dependent. And I do often, because the default in R in base R is to not have a grid background. I think for Kaplan-Meier curves, because I think of them as an analytic method, right? Like we do more than just look at Kaplan-Meier curves. We look at median survival and 5-year survival, and like we use the lines a little more analytically. I think I like them here, but it's a good point that like if you look at the plots, the line plots I did for like that violin dot plot I did, I'm not using the grid on that. You could I'd be fine getting rid of the grid on that.
Whenever I've jittered things, it has been when, you know, you've got like 50 dots on top of each other that appear to be one dot. But the
Yeah,
violin kind of gets around that, so
it
that
does.
jittering
Yeah.
and violining kind of makes it confusing because the dots happen outside the violin. And
Yes. Yeah. And there are actually functions to make the dots non-randomly line up beside each other in a jitter plot. So like you can see in those, like there are a bunch of dots kind of in sequence. There's a way, I can't remember what the command is because I thought it looked a little silly. But to make them like an actual width of dots, like it's right beside each, like edge to edge. Yeah, I'm torn on the dots on a violin plot. It's because yeah, you're right. You could do the jitter or you could do the violin plot. I don't know. I needed both. But it's just exploratory now. I would probably pick one over the other when it came to actually doing the like if I were to do this as a production. Because there's a bunch kind of weird about that plot. Homework.fact, like it doesn't need a legend. And I don't know if the confidence interval on the line of on the low S curve is necessarily the best, considering we're not. That's maybe adding, when you put a confidence interval on something, I think it adds an aura of authority. Like this is what I think. I went through the effort of calculating a confidence interval. I'm not super confident on the bounds of that line in any way. That was the default setting, and it communicates there's a slight pattern between the X and the Y. That's all I really wanted to get at.
It's so funny, like, yes, you can draw the graph, but what does, like, I don't know about the variable. What does it mean?
Well, yeah, and that's particularly true for that M10 data set I'm using in the second example, where I literally don't know what it means. I'm guessing at it because I searched for a bunch last night, and I thought, it's so frustrating. But at a certain point, it was easier to make it up, because I really like it as a data set, so I didn't want to go find another data set. So I thought it's easier for me to just make. I'm pretty confident that a variable called homework that they want to relate to grades that goes from 0 to 7. I can fairly confidently say it represents 0 to 7 days doing homework.
Yeah, it makes sense. Okay.
you know, Sam, I'm looking at the what is it? I don't know what this graph is called. Facet wrap tilde S chid. Oh, this is the homework and math graph with colorful dots, and there's a line for each school. Is this the kind of graph you would show somebody and say, therefore, a random intercept model makes sense. We were talking while you were gone, and I guess like some people might look at this and say like, I'm going to put a dummy variable in for each school. I'm going to put an interaction term in for each school.
So you could try. That would be a different approach. The reason you wouldn't do that is that I think you would need the interaction term. The model would collapse on the interaction term. There are too many schools. I just don't think you're going to be able to fit that data. I think one of the good general rules of thumb, and I'm not great about knowing when, I probably do multi-level models less than I should. Random effects are there when you want to account for an important effect that you don't care about. Right? So part of the, like you could certainly fit this model with like an interaction between homework and the 10 individual schools. But that makes it harder to identify what the core effect of homework is, right? It doesn't give you because what we've done now is we have a homework effect and a factored out. You could do that with the interaction model. It would be a lot harder to parse. I mean, anyone who's worked significantly with the margins command knows how challenging that can be in Stata, and it's better in Stata than in R. But more that I don't care what random effects are. Often the thing you care if there's an effect, but you don't care what the effect is. Like if you pull out the UCLA, if you go to the UCLA tutorial, they actually, the thing they do at the end is explore what the random effects were for each school.
Okay.
Because that's kind of interesting. But what I'm interested in the random effects isn't the coefficients, it's the variability of the coefficients. And I guess I can probably check what the I can't remember what the command is to get that.
Yeah, I mean, I'm interested in how like people justify picking a method when, like I know we're just talking here, but the recommendation that you came up with, we wouldn't write that in a grid. We would say something like else. I don't know. But here I'm looking at this image. Some lines go up, some lines go down, and if you were to say, "Oh, we're just going to make a random intercept for each school," it's like, well, what does the homework effect mean when we have some lines going up and some lines going down?
Yeah. So the idea, and well, actually, what we had hoped to be able to do was say, after we factor out the differences in schools, what's the holistic effect, right? So like, if you look at the actual equation, it's like beta 1x but plus. God, I can't remember what letter they use, right? So like there's an effect of homework, then there's a school-specific effect of homework. This is a pretty extreme example where after you factor out the school-specific effect of homework, there's nothing left, right? The baseline effect of homework was nothing. So this is,
So
I think.
it has a.
Yeah, go ahead, Yukiko.
It has a quite a bit. Yeah, it has a quite a bit of policy implication, right? So in the education, what to suggest and what's the standard way to recommend.
Yeah.
And homework, you cannot say homework is good.
Yeah.
Because it's depending on the school. Then you have to think about the school and homework if homework to be effective.
Yeah, and I think ultimately what you want to ask yourself with this one is, what are you trying to what is it ultimately you're trying to prove? I'd have to go back and see what the model fit rules are for I can't remember how to measure model fit for mixed effects models, but like ultimately we want to figure out why math scores are as variable and as low as they are. And I think what this current model shows us as is that it's not consistently homework. But the fact that homework is having a different effect in different schools means that either so you would want to dig deeper to see, are the schools assigning homework differently, right? Is homework different? Was the data captured differently? Is this self-report? Like, is this number of days homework was assigned or number of days students said they did homework? I don't know. Like, the results of this model don't tell me much other than math success isn't driven extensively by homework, and the effectiveness of homework varies wildly. So homework isn't a homogeneous concept, right? There's some schools seem to be making good use of homework, some seem to be making poor use of homework. but you'd want to look at a lot more, which might just be a matter of looking at the other variables in the data set. There's a lot of other variables there. I guess not a lot. Yeah, like sex, race, urban region. You at a certain point you would have to figure out what the data actually means too, which is a challenge because we don't know what schools or what country or what. Yeah, there are a lot of challenges here.
Yeah.
And then also the distributional assumption, right? So a fixed effect, random effect, and it's explicitly using random coefficient that the differences are coming from the under different distribution grouped by that group or cluster.
Yeah, yeah.
And then a fixed effect, you don't really talk about it. So the consequence is that then you cannot really tell from fixed effect model, meaning that the dummy variables, how much of the overall variation is coming from within and between clusters.
And that's often why, like, in this work, I think those 4 visualizations are probably more valuable than the actual models in this case, right? Because they're like that last line plot. Honestly, if I was working on this as an actual project and got to that last line plot, I would say there's no point in fitting this mixed effects model. Like I would have got to that point and said the mixed effects model is not going to tell us anything. Like there's too much variability between schools. The random effects are going to eat up all the effect of homework, and I would have predicted that homework doesn't have a fixed effect because look at it, like it's like the linear, when you fit the individual linear regressions, they vary from a slope of 7 to -4 on a variable. Like that's an 11-point swing on a variable that only has a 40-point range. That's wild. That's a wild difference. Intercepts between 59 and 38. Like it really seems to be apples and oranges. So I'd want to know a lot more about the data and kind of, I mean, I would fit the mixed effects model because I went through all the effort of setting up the plot, and once you get to this point, fitting the mixed effects model is one extra line. But I would know before I fit it. Like we're not going to dig super deep into this fixed effects model because there's a lot more here than what we're stressing about.
I have to log off, but thank you for entertaining my question about a data set that we don't really know about. I really was just kind of interested in the process, some lines go up, some lines go down. How do we use this?
I think my general rule with random effects is I use random effects if I don't necessarily care about the coefficients that are covered by the random. Like I know it's an effect, but I don't care about the values of the coefficients. But it is probably more complex than that overall.
Yeah. Is there an assumption with the random effects as well that they can't be correlated with any of the other covariates? So, because I know, like
you can get into multiple multi-level models. So like region, I think if we look at a table in that IM data set, if you look at a table of
Kent is trying to trap you in a discussion about the statistical property of consistency of everything else in your model when you use a random effects model. On an unrelated note, I have to leave now immediately. Goodbye, Kent. You've dug your own grave.
Yeah, so you
Thanks, Ed.
See you, Dan. You can run into this problem in that, this is a good example that the schools seem to come from 3 different regions.
Yeah.
So if you wanted to account for a regional effect as well, now if this is if this is England, it might not be as important. If this were Canada and the 3 regions were provinces, you would want to find a way to nest region as another random effect within the it's why we call them multi-level models and not 2-level models, because you can have multiple levels, right? So we have school nested within region, and so we want a random effect of school within region and a random effect of region. I'd have to Google how to fit that. It might just be as simple as putting. No, that can't be right, can it? Well, let's just try. No point in guessing. It's easier to break things than to school ID plus region.
Yeah.
Yeah, I don't know how to fit it. It's I know it's out there. I'm sure if I Googled it, I could figure it out. But I don't know how to do that kind of 3-level.
But you probably don't want to do that.
But I mean,
It's
like I said, if this was Canadian data, I
yeah,
really think region. Like if region was province, that would. If you forced me to pick
yeah,
between school ID and province ID, I would pick province ID, right? I think of the
yeah,
two,
yeah, right.
province or state in the U.S. would be similar, where there's
Yeah.
more variability between provinces and their policies than there is between states.
Then you really have to have fairly big data.
Yeah, I mean, this is going to fail because we just don't. There's no way we have enough observations.
Yeah, yeah.
Oh, so it's so if school ID is nested within region, you would do school ID / region. So it would look like this. Here, I'll stick it in the chat.
Oh, yeah.
So you can see school ID / region.
Okay.
And if you
So
run that,
that's
you get a warning that it fails.
smaller to bigger.
Oh, okay, cool.
So that's the way it shows that we have school nested within region, but then the results are all wonky because we just don't have enough data. Yeah, so if you run that model, you get a warning, but no, it doesn't. It's not an error, so it still works. But you can see, if you look at it, what you get is you get an intercept and a slope for each school within each region, and then an intercept and a slope for each school. So there's a school-specific effect within each region and a school-specific effect, and they would combine. The problem is that I've now wasted a ton of degrees of freedom on which is probably the right thing to do. It's just not that big a data set.
Yeah.
So situations like that, you could put one level as a fixed effect. Could you?
Yeah, so you could maybe look
Make
at
a priority of which one is more important. Well, I suppose you have to put the, I don't know which one.
And when you're calling fixed effects, are you saying are you calling them like the fixed effects?
Dummy variable.
Dummy variables. Okay, yeah, okay.
Yeah.
That's
that's one of the nice things about most of the time in our we don't actually care about the dummy coding of dummy variables. So like when I say a fixed effect of region, I really mean region 2 and region 3 compared to region 1.
Yeah.
But it just R takes care of all of it in almost all the libraries. There are some machine learning libraries that require you to dummy code your own variables, and there are a couple libraries, one called Fast Dummies, one called Model.matrix, that will take a formula and produce the dummy coded data set. So it'll you give it a formula and it'll give you the strictly numeric. Okay, bye Yoko. Give you the strictly numeric data set version of it. But I find I need that very rarely, but I am needing it more and more as I do more and more machine learning in R.
Oh, do you normally use machine learning in R, or do you do it more in Python?
I do it more in R just because it's where I'm comfortable.
Oh, yeah.
When I teach, I've taught our data mining class to our informatics students before. And because they have one stats class and one machine learning class, and because they do the stats class in R, we do the machine learning in R as well, just because they already have a head start there. The other nice thing about R over Python is that Python doesn't have anything as good as RStudio. Like there are the best kind of unified singular program to download and run Python might be RStudio. RStudio has Python support now, and that
Yeah.
might be the best way to do Python. Python's a phenomenal language. It just doesn't have an IDE as polished as RStudio. Or even, that's one of the advantages people had. Like, I learned Java when I did my degree, and one of the advantages that Eclipse was just an easy thing to run and install, and an environment to work with, so everyone's working in the same place.
Yeah.
Python, it's just nobody, and it's not, R existed for over 20 years before RStudio came out, right? Like, R was invented in the early 90s, and RStudio came out in 2011, 12, 13, something like that. Like, it's...
So you mean that?
Oh, sorry. You go for it.
So you mean that then when R was not RStudio, it was much less friendly or powerful?
There wasn't. It's the exact same system. It's just it wasn't as easy to write. There wasn't a program like RStudio that combined the scripts and the code and the help files and like these 4 panes. Like, you could actually open R yourself, and it has its own built-in text editor that's okay. And there were third-party software. Emacs was how I did a lot of my programming for a long time. And it had a way to, like, it was a text editor that you could send commands to R. There's a program called TinR, TINN-R. I don't know if it still exists, but it was a good way to write it for a while.
Mm.
You can actually do it in Visual Basic, so Microsoft's coding environment has an R extension, but none of them were as hi Samantha. None of them were as polished or as easy to use as RStudio in terms of the help integration and there are things in RStudio that make it really nice for teaching, like the environment browser in Kent's top right there. Like, that's a really useful thing to have. That makes it really easy for people to like, when you create an object, it pops up in your environment browser. It really helps people understand the workspace nature of R. You will eventually find you don't use it that much, but in the beginning, it's really helpful to kind of get, like, I type X equals 7, and then X appears in this box, and I can click on it and see it's a 7. And it's the help files being integrated is pretty useful.
I like how it shows the number of observations.
Yeah, like the summary stuff it does for data sets is pretty good. And I think if you click on, there's a little down arrow beside on the left side. I think it'll give you the actual individual variables.
Yeah, and then
mine is not set up that way. Maybe I'll change.
Yeah, I don't use the environment. It just gets in the way. I tend to keep R on my smallest of my 3 monitors, so I'm pretty short on space. Yukiko, I know you have, like, the world's biggest monitor there, so you can probably manage 4 screens. It's funny. I always tell people, actually not how. So I always tell people code on the left, console on the right. And I went to a presentation by the RStudio people, and they had it how Kent set up: code on top, console on bottom, with the stuff on the right being less important. The idea being that the stuff on the left is the important stuff, the stuff on the right is the less used stuff. And if your monitor is big enough, that's not a bad way to do it. My problem is if I take what's on the left and split it in 2, I find my code window is just too small. I can't see enough code at once. But if your monitor's big enough, I can see the advantage to having it set up this way.
Yeah.
Sorry,
yeah.
Where do you set up that? It's the preference and option?
Yeah, it's Tools, Global Options.
Okay, thank you.
And then pane layout is where you can move things around.
Okay, great. Thank you so much.
Yeah.
Okay, I see.
Yeah, I was coding with Python. Maybe I should switch to RStudio, but I was using Spider, and Spider has, like, a layout option that you can change it to RStudio's layout.
Oh, really? I haven't used Spider.
Well,
most of my Python programming has been with Jupyter, Jupyter's pretty neat. It's kind of like, it's like a built-in. It's like you're writing in R Markdown in real time.
Yeah.
But
yeah,
I don't know. I'm sure if I got used to it. My brother has he's transitioned slowly away, so almost all his work's in Python now because he works in mapping, and that's their de facto approach. Yeah. But it's I don't know. The Python environments just have never really grabbed me. I never feel like I know what's going on. I don't like the pseudo web server feel of Jupyter. I have enough tabs open. I don't want 5 additional coding tabs.
Yeah. I think Spider is. I like Spider a lot more for that. It's not. I find it's not as good as RStudio, but I don't know. I guess R was like the first language I used as well, and RStudio was where I learned it. So I'm kind of biased towards this default.
Yeah, well, I mean, once you've used a setup, even for like a week or more, you're probably not changing. You're probably used to it. You're probably not gonna change your approach then.
Sam, how would you model this exam?
Let me see. What did I ask?
Okay, I have to go. Thank you so much.
Okay.
See you later, Yukiko.
Thank you.
All right. So for a fixed effects model, I didn't actually do this last night, so.
Okay. See it.
Bye, Tom. So we're building a model.
Here, I can stop. I'll stop sharing my screen.
So we're predicting norm exam. But I just said based on the available data. So what do we want to predict with?
I use sex as a factor. I don't know. There are.
Sex plus stand LRT, I'll do. And then, so then we need to decide what the random effect is.
Stand LRT. Oh yeah, okay.
Right, so we need to decide both what the grouping variable is, and then if we want a random intercept or if we want a random slope or just a random intercept.
Okay. I can probably figure.
So the if we just want a kind of the place you would start is this command. Here, I'll share my screen. So I'm fitting a model predicting the normalized exam score with sex and the stand LRT score, which I should look at what that means before I do it. But and then there's a random effect of school. School is the grouping variable.
Yeah, okay.
Exam $sign school.
And then
yeah, so there are 65 different schools with varying numbers. So running this would give us a random intercept.
Yeah, okay. Yeah, because of 1.
Yeah, so that's at minimum you want that. Determining if you want a random slope is more complex. You need to determine what variable you want a random slope on, because I could get a random slope on both of them, both of my fixed effects. Oh, it didn't work. Must just be 2. Let's try like this instead. Multi-part random effects often fail. So this is now giving me a random slope for that stand LRT variable and a fixed effect. But I would want to investigate a bit more before I did that.
Yeah.
Just because, and we could probably, so if we did exam
level and
stand LRT y equals norm exam plus geom point. So that this is just a plot looking at standard LRT versus exam scores. That looks pretty good. And now if we do, so this is one of the areas that if we do geom smooth, we can get a line fit to it. And rather than doing a facet, what I might do is I might try grouping. I'm only kind of sure this is going to work. Let's see. School.
Oh, did you cut?
Surprised that didn't work. Do I need it?
Color by with that?
Yeah, maybe I need a color for school as well. School.
Huh. There's 65. Yeah, I guess that would be a long legend.
Anyway, I would play around with that to kind of see. Let's try that.
Are we gonna do GEE next week?
Yes, I think I will.
Cool. Sounds good. Yeah, I'm not familiar. It's funny. In economics, I had never heard of the term. Oh, there you go.
That doesn't give me the lines though. The dots aren't like that's not the dots aren't readable.
Yeah, because you don't know what level.
Yeah.
Could you put group in the smooth? Is that? I
just tried that. I want to see what happens if I try putting it in the core.
Almost if you you almost have to do like individual smooths in a way. Like a bunch of them, 65.
Yeah.
I don't know.
Yeah, I'll have to play around with it. I'm not sure. I'm surprised at this. Oh, it's there.
One. What's NLS?
I don't know. I'm just Googling.
Oh, okay.
Yeah, I'm not sure. So it's you. I would want to do a little bit more investigation to figure out what the best way to approach that slope would be.
Okay, yeah.
And try and figure out if a random slope seems appropriate here, and then just play around with the other variables. And so you need a bit of investigation, but the kind of this is the starting point, like fixed effects that we're interested in, and then this is the base kind of grouping that you would have to investigate. I'd have to be awfully convinced that there isn't a random effect of school before I factored it out. And this is a good example of what Dan was talking about. Like, do we want school as a random effect or as a predictor? There are 65 schools, some of which are very small.
Mm-hmm.
I can't imagine we want 64 individual coefficients because we're not interested in comparing the schools to each other. We just want to know if schools are different, right? And then we want to factor out that school effect so we can say after factoring out the effect of school, these are the fixed effects.
Could you do like I think in other places, like when I think of a fixed effect, I think of like a within estimator, so like the difference from the average. I don't know. Have you used
I'd have to think about that to see how that works, like how the effect, and this is something that I've always if I fit it like this, so Standal RT has both a random slope and a fixed slope. I
Yeah.
think of fixed slope as this is the effect of Standal RT after I've factored out a school-specific effect of Standal RT. But how exactly that works when I start thinking about it more, I'm not the most confident.
Oh, okay. Yeah. Oh yeah, I was gonna ask So we would use the GEE package.
Yeah.
That's what you're. Okay. Yeah. Yeah. I was wondering because in my master's program we talked a bit about the generalized method of moments, the GMM,
Okay.
and then yeah, and I never heard of anything about the GEE, and I don't think we did it at any of our assignments or anything, but I think
So it's interesting. This is a summer lecture series I did for the EPI students,
oh, okay.
I guess 4 years ago now. And there were a bunch of them. There were several of them that needed kind of an update on specific regression methods for their thesis. So
Yeah.
between their first and second year, they just asked for a lecture series. So I might have only done 2. One was on like linear logistic Poisson survival. And then the second one was on GEE and imputation. And that was because there were like 3 or 4 students that needed GEE and imputation and they didn't feel great about it. I learned GEE for this lecture. I didn't know it.
Oh.
I hadn't. I don't know if it's just that young.
I talked to one of my professors from UBC, and he showed me how you get from. It's like a specialized version of generalized method of moments,
Oh, okay.
where what did he say? You use the optimal.
I like this sentence in on the Wikipedia article. This relationship is immediately obvious from the requirement that the score satisfy this function. So yeah, this function right here should make it immediately obvious why method of moments and estimating equations are related. So just look at this, Kent. Look at this and understand why method of moments and estimating equations are the same.
Yeah. Yeah. I actually
Asshole Wikipedia article.
Yeah. Yeah. The people on Wikipedia are kind of.
The stats articles on Wikipedia are really top notch. I feel sarcastic sometimes linking to them, but especially in Biostats 1, they're so good for intro biostats stuff. And it's funny, one time there was one, I can't remember what it was. Some guy named Fox had written, but I came across a Wikipedia article that was poorly written during my PhD, and so I had to email the author, and I asked him some questions that I pointed out, and then I went back later, and it had changed by a user like AFox. So like, I pointed out that the Wikipedia article that covered his method was poor, and within the next year, it looked like he'd created a Wikipedia account and fixed it. Like it was, and I think that's part of the reason that these are good is that they're often Wikipedia can get very political very quickly with new stuff. A lot of the stat stuff isn't changing. Like estimating equations aren't going to change now. So one person does a good job writing it up and it's just there, right? And it's just, they can be a little technical sometimes, as as you can see here.
Yeah.
But I find there's so much good stuff here. I like, yeah. When you were asking about that, my thought was, I bet you the Wikipedia article has something there.
Yeah, I'll show you. I think my prof actually. I don't know if you can see. Yeah, so GMM is the same thing as GEE, except for when you choose this function.
Oh, when you use a specific function.
Yeah, yeah. So the specific function that you use for GEE is just the optimal one. So I guess that's probably what you would generally want to use more often anyway. So I guess that's probably what the Wikipedia guys are getting.
Yeah, yeah. But yeah, I like GEE because it doesn't impose the same strict data structures that using mixed effects for longitudinal data analysis require, right? Like it allows you to have varying varying time intervals.
Yeah, that makes sense. Yeah, right. I should probably let you go and get back to my.
Yeah. I actually. Oh yeah, I have to review something for ethics before 12:30. All right. Well, nice to see you. See you next
Yeah,
weekend.
thanks, Sam. Yeah, have a good weekend.
See ya.